And let me see if I can find my Zoom here. I mean my screen share. Okay, pretty sure this is the wrong course. So let me get to the right course, Physical Science 111. You can probably see my, there we are. All right. And it's test 6 is the one you're talking about, right?
Yes, sir.
Okay. Now, some of these went by the weekly assignments, and some of them did not. Okay, we had 9 chapters in 8 weeks, so we doubled up 1 week, and I don't remember if that's the one that we doubled up on. So let's go to. I've got to move y'all out of the way for a moment here. Blackboard is really hard to navigate when you're in Zoom, so it's hard to navigate anyway. But all right, so let me open up this, and we'll start with week 6. I don't think that's going to be the right week, just to see if it's there. I doubt if it is. No, we have test 7 that week. So let's go back and close week 6 and go to week 5. Okay, there's the chapter 6 test here, or at least this is one place it could be. Let's open this and see if it's there.
I was going to say, when you open up that document, it doesn't like bring you to a test document, you know?
Okay, this PDF right here. Is this where you got to? Test 6, chapter 19 test. Is that where you're at? It's under week 5, I believe it was. And it's listed as test 6, chapter 19 test. Okay, when you click on the 3 dots here, it says download original file, right? When you click on download original file, then you'll see it downloading in the corner here. When it finishes downloading, you can click on that, the lower left corner, click on that, and there's your test. You'll have to rotate it some.
Yes, sir. Yes, sir. See, I was thinking like test 6. That's why I didn't know if that was the correct test or not.
Yeah, that's it. It's different from the other tests because the test bank questions were just absolutely wacko on that one. So I had to rewrite my own question. I used basically what they were trying to get at, but I had to rewrite them so they were more things. So that's what you got. Is that was your question? Yeah, that is test 6.
Yes, sir.
Now there's 10 questions, but you see many of those questions have multiple parts, so it really comes up being like 16, 18, something like that possibilities. So it's not quite as bad as it might seem like, but it's a 1-page test. It does look different from all the other tests, but that is the chapter 19 test 6. Okay? All right, so that answers that question, huh? All right, so let's get out of this then. Let's see, if somebody else tried to come into class, let me see if they have, if someone's in the waiting room. Yeah, Brianna is in the waiting room. Sorry about that, Brianna. Let's get us in here. All right. Brianna, sorry if you had to wait a while, but I was finding a test for another student, and the names that Zoom puts up here was covering that you were trying to get in the class, so I couldn't see that was happening. So I'm going to get out of, move y'all around a little bit more, and I see no reason to continue here, so I will close that off, and then I'll just minimize this and go back to screen share here. Oh, wait, there's somebody else trying to come in. Jackson's coming in, so let me get Jackson here. Okay. Let's minimize that for a moment and go back to chapter 24, and we'll go to current slide. And okay, now let me just check one more thing first, see if I got everybody here who's here. Should have 10 students here. 1 2 3 4 5 6 7 8 9 10. Got it. Hopefully more will be coming in, but I've got the 10 of you here. All right, any other questions before we get started on chapter 24 today? We're finishing chapter 24, which is finishing all the course material for the course. We'll still have to go the lab for chapter 24, which we'll do on Tuesday, and then I'll post the test for chapter 24 also on Tuesday, and probably either Tuesday or Wednesday post the test, the final exam as well. Now, what we'll do today is, of course, finish chapter 24. But then at the end of that, I'm open to any questions, any problems, any issues, any concerns on any of the labs, any of the tests. And let me just make this request now. If there's any way possible that you can wrap up and finish all of your labs and all of your tests, that would be labs, okay, let me back off. The research paper, okay, finish the research paper. All the labs, that would be labs 1 through 8. That's covering chapters 14 through 23, the ones that we did, okay? And all your tests, 1 through 8. That's chapter 1 through 23. And here comes Denisha. Let me get her in before I say anything more. All right, that gives us, it should be 11 students. 1 2 3 4 5 6 7 8 9 10. Whoop. 3 4 5 6 7 8 9 10 11. Should have 11 students. That's right. Okay. Now, for those who just come in, let me repeat a little something here. Today, we're finishing chapter 24, which is the last chapter in the course. Okay? When we finish today, at the end of class, when we finish whatever we do, and it's probably going to be way before the end should be, I will be here to answer any questions you have on any of your last labs, any of your past tests, your research paper, any questions you have whatsoever. And if we run out of questions, there's nothing else to do, then the rest of the time is for you to catch up those things done. And this is what I was saying just before the last person came in, was this. Now, someone I think has his microphone on. I can hear something in the background. Okay. What I'd like to ask you to do is, if you can, get your research papers completed this weekend if possible. Okay? I will accept them Tuesday, but you see, Thursday is final exams day. I would rather, in fact, you'll lose points if you don't have them in before Thursday. Okay, so Tuesday, please try to have your research papers completed and turned in by Tuesday. Try to have all the labs 1 through 8. We'll be doing lab 9 on Tuesday, so try to have 1 through 8 labs completed and turned in by Tuesday. Okay? And try to have all your tests 1 through 8. They've all been given to you so far. Try to have those completed and submitted by Tuesday. And that way I can be grading on those while y'all are finishing up your lab for chapter 24, the current lab we're on now, the current chapter we're on now. You can be finishing your test for chapter 24, and then if you have time, by Thursday, have those labs finished, have that test finished, and have the final exam completed. I'll be here every day. Tuesday, of course, we'll be doing the lab for this course, for this chapter, and answering any questions you have on anything else. If you had problem over the weekend getting a lab completed, getting a test completed, finishing your research paper, I'll answer any questions I can and then give you more time to work on those, but try to have them in sometime Tuesday. And then by Thursday I'll be back here again, and that's for you if you have any questions on the last lab, the last test, or the final exam. That will be the time for that. So that's how we're going to wrap up the term. Are there any questions, issues, concerns, problems? Earlier today, for those who came in a little later, a student was asking where test 6 was. So I took him to test 6 and showed him where it was and how to access it. He wasn't sure that was a test because it didn't look like the other test, but yeah, it was. It's one with fill in the blanks mostly, a couple of maybe multiple choice, mostly fill in the blanks, because the test bank questions for that were, I thought, outrageously vague, and so I didn't like them at all, so I turned it into a fill in the blank type test. Okay. Any questions on what I just said? All right. Next question I have for you is a different kind of question. Have any of you seen anything about student course evaluations for the first mini-term yet? Has that been posted? Nope. Okay, I was afraid of that. This is our first term with this new banner system, and it may be they're having trouble getting the course evaluations done on banner, or the other option will be they've forgotten about it, and I don't know which is the case. So if I can talk with someone this weekend or tomorrow, I'll try to find out if they're going to do student course evaluations, what will be involved with that, how to do it. My guess is they've forgotten about it because they tend to forget about mini-term courses, okay? But the second issue maybe is a banner issue and they don't have it integrated in banner yet. And that may be because they've forgotten about the first mini-term. So I'll try to find that out and have that information. Well, hopefully they'll be posting something over the weekend or no later than Tuesday, so we can talk about it on Tuesday. If they get it out there, please do the student course evaluations. Those are very valuable for us, so please try to do those. All right. Now, open it up to you. Do you have any questions, issues, concerns, or other things? All right. Yes.
That's the Lab 7.
Okay.
But it was empty. There wasn't anything on it. And I think that was some mistake. I was wondering if I could resubmit it.
Absolutely. Absolutely. And now, I believe I may have sent you a message on that. Whether you get these messages or not, this is something so stupid about Blackboard, okay, as if there's not plenty of things stupid about it. But when I saw that, I did a message, but then I got something that flashed up and said, this message will be sent once you've posted the grade. Well, I didn't want to post the grade because it was a 0, but yeah, so I did send you a message, but I don't know if Blackboard delivers the message until I get the grade posted. So yeah, so absolutely, I saw that. Another student had forgotten there were 2 pages on a test, and she got that done. It seems like maybe another student had an issue similar to that. So if you haven't gotten something back, now maybe I'm still working on it. I've got everything graded I printed, but I may not have printed everything. We were out of town last weekend, so I couldn't print a single thing over the weekend. Where we were is very weak internet, so I was afraid I wouldn't be able to do anything. Well, it's through the phone. It's DSL line. The phones went out Friday evening and didn't come back until Sunday evening. And it wasn't just our phone, the whole area there, everyone's phone was out, and if anyone was on DSL like we were, their whole internet. So I couldn't even look at anything or check anything, much less we didn't have a printer, so I couldn't print anything anyway. So I'm way behind on printing. And then last evening we had to go up to Jasper. My wife's old car is approaching its last days, and so we had to get her a little bit better car, and we found the best deal up there, so we had to go up there and pick up the car yesterday. So I've lost bunches of office hours this week driving back on Monday and also having to go yesterday, so I haven't had a chance to get hardly anything printed. And here comes Diana. Let me let her in the class. And there she is. So that should have us up to 4, 5, 6, 7, 8, 9, 10, 11, 12. Should have 12 students here now. Let's see. Yep, that should be right. Okay.
What's the deal with this Lab 5? You still haven't checked mine.
Okay, Lab 5.
Yes, sir. You told me that you didn't have it, so I sent it to you again Tuesday.
How did you send it to me on Tuesday?
The same, through Messenger.
Okay. Now, I think I just got through saying I thought we were out of town last evening, so I didn't get any time to print anything, so I'm behind in printing. So that's probably where it is. Okay. But everything that I printed so far for this class I've graded. Now some of my other classes I'm still behind, but for this class everything I've printed I have. I am way behind on email, so if you sent me something through email, just hang on. I'm hoping.
I guess I misunderstood what you said. I thought you said that you had everything graded, and I noticed that that was still not graded. So I said, well, if you graded everything, then I need to bring it to your attention. That's all.
Okay, yeah, everything that I've printed I've got graded for this class, but I haven't printed everything because we were out of town over the weekend, so I couldn't print a thing, and the internet was down to boot. And then we were out of town again last evening because we had to drive up to Jasper and get the vehicle, and we thought it was all taken care of. And well, first my wife had to work late because a meeting that she thought was going to be over at 4 went way past 4, and then she was interrupted twice by people who work with her having her questions for her, so she was very late getting home, so we're late getting up there. And once we were there, they took forever. Okay, and so we were very late getting home, so I had no time to print last night either. So hopefully tomorrow, knock on wood. Now I think I do have a departmental meeting tomorrow, but hopefully that's all, and hopefully I can knock that off pretty easily and get things caught up. But then we got Saturday and Sunday. We're going to try to, like everything, not have too many things interfere, so I can try to get everything caught up over the weekend. Don't know that I will, but I'll do my best to do so. And then Monday is not going to, well, I'm sorry, Monday I'll have some time, and Tuesday this class will not take us long to complete, so I have more time to get things done. So hopefully in the next few days I'll get most of the printing caught up. Once I get the printing caught up, I'll get the grading caught up. Once I get the grading caught up, I'll get it on Blackboard. I think I've got just about everything on Blackboard that I've graded so far, but I've got to check that because some things come in one way, some things come in the other. I've got to go back and confirm that everything's made its way to Blackboard gradebook successfully. So I can't promise anything now, but I'm going to try my best to get it done as soon as possible. And like I said, I've had no time for printing since, oh goodness, I may have printed a little bit yesterday morning, but not a lot because I was catching up other things yesterday. So basically I've hardly printed anything since last week, about the time this class was over with, because Friday we were out of town, Saturday out of town, Sunday out of town, and then last night. Yes?
So by printing, you mean like if we sent it to you in an email?
Yeah, if you send it to me in an email or Blackboard message or through Blackboard somehow, I haven't gotten anything printed in the last several days.
Okay, yeah, because I've sent it on my work through email.
Okay.
The task that we were talking about last time.
Okay. And here's the other thing. I can't remember which day it was, whether it was yesterday or the day before. My computer and it was this class. Remember how slow my computer had gotten on last Thursday? And y'all all had the lab opened up and mine was still sitting there trying to open. It was just awful. Well, then after class got over with and I started trying to print things and other things, the printer and the computer were not communicating. I'd print one thing and it would take forever for it to print, and then I'd do something else and it would say unable to communicate with printer. Well, it just had communicated with the printer, so I knew that wasn't an issue. So I kept doing. Finally, I had to shut down everything. And when I got everything shut down, bring it all back, and then it printed better. But for a while, I was able to print almost nothing. And last night, it happened again. In fact, right now I've got the printer off because last night I was trying to print something. I don't remember if it was this class or another class, and it just started spitting out pages with just garbage printed on the first line of every page, and page after page after page, and I had to shut it down twice because it did that twice. So I left it off overnight hoping it was going to straighten itself up, and I'll get the printer back up today after class and start printing things. But like I said, I have to get a preparations for a departmental meeting tomorrow done, but then after that I hope to be able to go back to and get some things caught up. So yeah, if you sent anything recently, especially email, I'm just way behind on email because I wasn't able to access any email. Basically, I've hardly seen any email since last week at this time because we were out of town and I couldn't read any email because the internet was down. So, any other questions? That's all my sad song. You hear the violins in the background. Okay. Any other? Yeah.
I wasn't able to get into class Tuesday, and I was wondering if there's anything I could do to make up for my absence.
Okay. Number one, we recorded everything on Tuesday and it's out there on YouTube video. Now, how to access those YouTubes, and this is for all of you, for any time you may have missed a class, especially missing a lab, okay? Because I've recorded everything, all the labs, everything that I could. Now, a couple of the labs you've done somewhat independently, like when you did the ones on the minerals, okay? I gave you the website and told you how to do it, and then y'all did that on your own. I stayed online as long as anyone wanted me online, but y'all could do faster if you were not having to be online here and trying to look up the things. So that one, there's not too much except how to do it, but you can find out exactly what we did in class and what we said. Also, the latitude longitude one, I gave you the directions for what to do and stayed online answering questions as long as you needed me to, and then y'all took off and did it on your own. Except for those two labs, just about all the other labs are out there, and they're out there under it's a YouTube videos under the playlist for this class. The link for that is under week 1 instructional materials. That's the second tab under week 1. The first one is overview, and the second one is instructional materials. If you open up instructional materials, you'll see the PowerPoints are at top, and I think right under there is recorded lectures for the classes. This is all set up for online classes. Doesn't really fit here, but because I record all of our classes, you can go to that site, and under week 1 I gave the link. It's a web link. You can go to that. It'll open up the playlist, and the ones at the top are from past terms, the ones at the bottom are from this term. Now remember, the first almost 2 weeks of the term we didn't have Screencast-O-Matic, so I could not send the things to YouTube. But those labs are out there from when I did them last summer. Same labs, maybe a little bit of difference, like the evening sky map. The one from last summer was for June. The one for this term was in August. So you may have a different sky map, but it's the same questions, same stars, same answers. It's just maybe the locations of the stars are a little bit different. So you can either do it using June's sky map, or you can use August sky map. Either one, they're both out there. One's under I think you can access through the YouTube video from summer, and of course it's not a YouTube video, but it's out there on Blackboard for fall. So specifically Tuesday's lab. Tuesday's lab, we did everything together as a group, and it's all on YouTube. So go to week 1. Now you can go to any week, and every week under instructional materials, when you get to that place, it'll say please see the YouTube videos playlist link given in week 1. So go to week 1 and go to that playlist, open it up, and you'll see every class we've had, every lab we've had is out there. The labs are toward the end of the class, so you either have to slug through the whole class if you want to. If you miss the class, you may want to do that. Or you can fast forward, you know how to operate those things, and get to the place where we start the lab, and then you can do that. So it's out there. You just won't be able to ask any questions. So if you have questions, great things to ask Tuesday, because we have plenty of time for those kind of questions on Tuesday. If you get the questions before the end of the period today, we're going to have time at the end of the day too. If we ever get started on chapter 24, we'll have plenty of time to answer questions into. Okay, did that answer what you were asking? Okay. All right, good deal. Any other questions, issues, concerns, problems? All right, if not, where we left off last time, we're in chapter 24, the last chapter in the book, last chapter we're going to cover. If you've got the big old book, it's on page 622. If you have the little books that they sold in the bookstore, it's probably listed as 24-17. Okay, what we're talking about here, we had talked about, the previous slide dealt with a couple of slides dealt with the characteristic of waves, the wave length, the wave height, the wave crest, the wave troughs, the wave period, all those kinds of things. And then we talked about what created the waves, the swells, and that kind of stuff. Where we are now is basically somewhere on page 622 or 24-17. I think we're right about the left-hand column, the paragraph that starts just under the middle part of the page. It says, as swells move from the deep ocean to shore. That's what we're talking about. That's what we mean by shore effects. What we were talking about before was waves out in the middle of the ocean, swells out in the middle of the ocean. Okay, that's where they start. That's where they build. That's where they create. But we see the effects when they come to shore. Okay, and some of these shore effects that we see, the first one listed here is refraction. Now let me give you a quick and dirty meaning of what refraction is. Bending, and that's what it says right here. Okay, what happens when a wave is coming in, say here's the shoreline, say the wave's coming in at an angle, okay, coming in at an angle. Well, this part of the wave is going to hit the shore before the part back here does. So what it does when it gets close to shore, it slows down, because the shore effects, that's what we're talking about here, friction, other things like this slow it down. So basically your wave looks like it bends its way in. It's kind of like it's parallel parking, but it's not quite that way. The wave front bends toward the shore. And I don't think they have a particularly great illustration of that. I can't get it to advance. Okay, That's not a very good picture of that. That's a picture of what's coming later. Let's see if we can find a picture of a wave bending. That's the swells. These are shore effects. Okay, that's not a very good picture of the wave bending. Ah, here's a little bit, but not a particularly good one. We may come back to that one. Now, I guess we'll have to. Let me see if there's a better one in the book. I think the best one is probably this one here. You see, those waves came in straight, and because the shore is uneven here, it bends toward the shore here, toward the shore here, so you have bends in the wave. When they were coming in, they were parallel. As they get close to shore, and they were, in a line. As they get close to shore, you get the bending. That's what they mean by refraction. The shoreward side slows down, and the wave front bends toward the shore here, and also toward the shore here. This part here bulges out. Okay. Now, what do we mean by breakers? Now, at depths less than the wave height, remember, let's go back a couple slides. There's the wave height. From crest to trough, that's the wave height right there. From the crest of the wave to the trough of the wave, that's the wave height. Now, when the wave comes into shore, okay, shore goes down like this, and the wave comes in here. The wave height is this. All along here it's fine, but when the wave height gets less than the shore depth gets less than the wave height, then you have the lower part slows down, the top part breaks forward, and that's called your breaker. Okay? Breaker, no, okay. The surf is in the breaker formation zone, and those people who like to go out there and surf, that's what they're trying to ride. Okay, now there's several reasons for that. We'll talk about those as we get to them. So here's what's happening. Yuck. Here's what's happening. The waves are coming in, deep water waves are coming in like this. Most of the time you don't have white caps. It's only if it's very, very, very windy do you see those out in the deep ocean. But you definitely see your waves, sometimes the swells. They look just like this. And as long as the wave height, okay, is less than the depth here, they continue that way. However, even out here, you start getting some effects from the bottom, even though the bottom's not bothering you yet. But when this wave comes in, and now the wave height is less than the depth that you have here, what is happening here? I wish they had these lines reversed here. The downward arrow on the bottom and the upward arrow on top. I just would prefer it that way. What you have water coming in, right, with the waves. But it can't go anywhere, so it has to go back out again. And that's why I wish they put this arrow on the bottom. Because now you got water coming in this way, but water going out on the bottom, and that slows down that wave and makes it break. And that's what the breakers are. Here they were just nice, even swells. And here when it starts undercutting by their own return, water return, then the bottom gets knocked out from under them and they break. And this is then forms the surf zone where the breakers are. And that's where the gals like to get up on this wave and ride the wave in. Down here you just go up and down with the wave. It's not that much fun. Here they get to go in the upper part of the wave. So that's what's happening. The surf is in the breaker formation zone. That's where the surfers go. The water is transported toward shore by the breakers. It's got to return somehow, and it goes underneath. That's called the undertow, and that's why I wish they'd have put the under arrow underneath, the incoming arrow on top, the outgoing arrow on the bottom. That's the undertow. That's direct return of water underneath the breakers. Okay. Now, certainly that makes the breakers, that makes the surf, that makes it pretty, it makes all that, but guess what? It also makes it dangerous. Because if you're out here playing around, tooling along, and those waves get really fierce and lots of energy, then that undertow gets pretty fierce too. And the waves up here, if you get caught in the undertow, you could be dragged under the wave just like the bottom of the wave's getting dragged, and it may be hard to get back up to get air. And a lot of people drown because of that undertow. Now, let's talk about the longshore currents. This is a motion. It's not an actual current like we're going to talk about a little bit later, but it is a current. It's a motion that's parallel to the shore. Okay? Now, I think I've mentioned to you before, I'm not a very big beach person. It's a fine place to go, fine. I prefer shade to sunlight, and you don't have much shade on the beach, so I'm under those umbrellas as much as I can be under there. But I do like to get out in the water and play a little bit. And what I like to do, and I'm not very good at it, is what they call body surfing. I don't have a surfboard. I'm not about to invest in one. I'd probably not be able to stand up on it, so not going to do that. But just getting out here in the waves and then try to swim as fast as you can, caught by the wave, and ride it into the shore. That's idealistically. In reality, I'm not very good at that. Okay? But I've been out there sometimes for several minutes, maybe fractions of an hour, playing and doing stuff, and then I'll find myself walking up on the beach and not recognizing a thing. I cannot see where my wife's family usually were the ones that went to the beach, where they are. I can't see where our tents are set up. I don't see where our coolers are down there. I don't see anything. And I have to turn around and start walking up the beach. I'll look and see which way it looks like the currents are, or just by the geography where I need to go. And sometimes I've had to walk maybe half a mile up the beach to find out what happened. What happened when I was out there playing in the water, I was in those longshore currents, motion parallel to the shore, and every time I was going out and riding a wave in, going out, riding a wave in, what I didn't realize, that was pushing me further and further down the beach. The motion is parallel to the shore, and I got washed. So I got out, tired, wanting something to drink, and had to walk about a half mile in the sun, in the sand, hard walking, all that kind of stuff to get back to where I wanted to be. And then I said, I really don't like the beach much at all. Okay, so that's the longshore currents. I don't know if any of you have ever experienced those. You play around in the water and suddenly you find you've been washed way down shore from where you went in. That's the longshore currents. Now, they can also produce what they call rip tides, especially when they enter a channel. And this is what this shows. Now, this doesn't really do a really good job of it. You can just tell by the coloration here that there must be a channel going out to sea here. And if that's the case, these longshore currents could come down here and then get forced out here. So if you're being dragged along here, you might just get dragged out to sea here in these rip tides, okay? When they enter a channel here. You can't see it above the water because the water is all level. This airborne view, you probably wouldn't be able to see this, but you see by the difference in colors, there's got to be some activity going on here, okay? And those are particularly bad, the rip tides. They're even stronger than where it's undertow. They're like the undertow, but they also are pulling you down, okay, and out to sea. And I think I got caught in one of those. It was beginning to be sort of a stormy day, but it wasn't. They hadn't put up the warnings yet, but when I was in Virginia Beach, when I was in the Navy, I had family that lived in Virginia Beach, and they wanted to go to the beach one afternoon that I was visiting with them, so I happened to have my trunks with me, so I went with them. But it was a particularly rough day, a little bit rougher than normal, and I was not a very good swimmer, and I started just every time I come up, I was getting pulled further back than I was able to swim forward. And I wasn't able to ride the waves because I got behind the waves here, and I was beginning to be in trouble. Unfortunately, my cousin's husband was a very good swimmer, and he came out and gave me a hand. I'm not sure what would have happened if it hadn't been for him, because I was in a riptide that kept pulling me out more than I was able to swim in. And the water was rough, so every now and then I was getting a mouthful of water. It was not a pretty picture. Be careful. Undertow will pull you under. Riptides will drag you out. Okay. Doesn't sound too promising, does it? Here is that rip current. Under here, the other thing creating this bending here is the fact that the water underneath is going out. You don't see it going out, but that's the rip current, also sometimes called the rip tide. Longshore current is pulling you down this way, and then all of a sudden you find yourself being dragged out to deeper water in those rip currents and rip tides. Okay? You can't see it from the surface, and you don't even realize it's happening until you look up and you say, hey, I'm further from shore than I was earlier, and I thought I'd been swimming to shore. Well, that's because the rip current is dragging you outward. Okay. Now, I don't know if you recall back in the moon chapter, that was chapter 16, I believe it was, when we were talking about tides, they threw in tsunamis there. No, I'm sorry, it probably wasn't the moon chapter. It was probably the earthquake chapter, which, now I can't remember which one that was. That may have been chapter 19. I get all the numbers crossed up. Somewhere back there, a result of an earthquake, and that's where it used to be in the book, is when ocean waves are created. The earth shakes under the ocean, and this seismic wave makes its way to the surface, and that creates a huge surface wave. That's called a tsunami. It's, I think, a Japanese word, and it means a big wave. These ocean waves are not caused by wind. They're caused by earthquakes. Okay? Now, a few fairly recent examples of this. I'm just going to guess on the date here. I'm guessing about 6 or 7 years ago. Time gets crazy when you get old. It seems like no time, but it's been a long time. There was a fairly major earthquake in the Indian Ocean on the west side of the peninsula, where Indonesia and so other countries live in that Southeast Asia, and then there's a whole bunch of islands that go on out there. There was an earthquake near there, underwater, and that created quite a major ocean wave that made its way all the way across the Indian Ocean, and India's on the other side of that, and one of the seaside towns or cities there used to be called, goodness, I can't remember that. It's now called Chennai. Used to be called Madras, India. Pretty major city, fairly close to the ocean, and lots of people were out on the ocean that day. They had a little bit of warning, because that really isn't a very large distance for it to travel. Sounds like it is for us, but we'll see in a minute how fast they travel. And all of a sudden the tsunami came up and wiped out all these people playing in the water, in the ocean, having a good time. Seems like it was a Sunday afternoon, lots of people off work, stuff like this, and it was devastating. Okay, we have friends from, used to be called Madras, now called Chennai, and they had family that were living there, and they've either had heard or suspected, they were probably on the beach that day, it wiped out communications towers. It wiped out all sorts of things. They couldn't get in touch with them. They had heard there were a lot of deaths. They didn't know if their family was involved. It was a really trying time for them at the time. It turned out that just about all the family members they knew of, I think all of them survived, but they had friends or friends of family members who didn't survive, because those are pretty major. These can be the largest of all the ocean waves. All the wind in the world has a hard time coming up with the energy from an earthquake. The physical characteristics of these, the old name for them were tidal waves, okay? Tsunamis are tidal waves, okay? They have nothing to do with the tides. That's why they don't use that name here, but they used to call them tidal waves. They have nothing to do with the tides. That's why I was thinking that was back in that chapter, but it wasn't. It was in the earthquake chapter. They can be the largest and most destructive of all the ocean waves. Here are some of their physical characteristics, and this, to me, is hard to believe. The speeds can approach up to 700 kilometers per hour. That would translate to 420 miles per hour. A wave coming in at better than 400 miles per hour, you don't have much warning. There's no way you can outrun that thing or outswim that thing. It's going to get you, okay? The wave lengths are up to 200 kilometers, okay? What is that? That would be about 120 miles of wavelength, okay? Now remember wavelength, crest to crest. There can be more than one. It's not just one single wave coming in. It can be a series of them, and they can be up to 120 miles apart. But if they're traveling at 420 miles per hour, it's not going to take them that long to get there between that first one and the next one. And the wave heights out in the deep ocean, usually no more than a meter, a half a meter. That's about from your shoulder to the tip of your finger. That's about half a meter, okay? But when you get into shore and the shallow water, they build just like we saw those other waves building, okay? And when that happens, they can go up to 8 meters high. Okay, now I think I've said this before. This wall behind me is approximately 10 meters high. 3 meters high. 3 meters high. So basically it would be a building like a 3-story building to get up to 8 meters. Not quite 3-story building. Have a wave the size of a 3-story building coming in at you at 400 miles per hour. That's not going to be anything to play with, okay? So it can reach 8 meters in depth, height in shallow water. Now, let me go back further in time. I think we mentioned back in the earthquake chapter the strongest earthquake ever recorded on the Richter scale was like a 9. And we've had several that were close to that, but the big one that is most infamous, you might say, was off the coast of Alaska. Now you know where Alaska is, up in the way northwest, but it was just off the coast of Alaska, underwater. It created a tsunami that made its way all the way to Hawaii at an incredible speed, incredible height. Now this is back before I think Hawaii was a state, but it was populated and inhabited, and it wiped out a lot on the northeast shore of Hawaii. I mean, wiped it out. Hawaii wasn't built up the way it is now, but it really wiped things out then. Okay, evidently Denisha must have gone out and come back because she's already been here, so glad she's able to come back. Okay, so that was another example way back in history before my time and your time. But let's get another more recent one. There was an earthquake, underwater earthquake, off the coast of Japan. Now this time, the damage didn't happen so badly going out to sea. The wave that went back toward land, that wave was the one that wiped out the nuclear power plant in Fukushima. You probably have heard and read about that. The Fukushima nuclear power plant was completely swamped by that wave. Now, you might have thought, well, that just shut it down. No, it didn't just shut it down. It broke power lines and everything else, and all the built-in, and Japan had done a fantastic job of building in safety measures upon safety measures upon safety measures, and all of them were dependent on having power to pump water out, to do this, that, and the other thing, to cool it, to pump water in. Yeah, everything depending on having power. That tidal wave wiped out the power for miles around, and they wiped out their backup power supply. Their generators were swamped. Everything was swamped, and they had a very major nuclear disaster there. But because of their careful planning, their great construction, they isolated that. They had it completely isolated, and it didn't turn out to be a major disaster like Chernobyl did. It could have been worse than Chernobyl, but because they took care of things, it was major, but it wasn't that bad, as bad. It probably was not even as bad as our 3 Mile Island event. And that was, we had a lot of safety measures on ours, but they had done even a better job. And ours was not caused by tidal wave, which was nature doing it. It was a mistake on man's part. And so kudos to the Japanese for it not being any worse than it was. It was still very bad. Lots of radioactivity got washed into the ocean. It did cause quite a few deaths, I'm sure. I don't know if anyone's ever tallied them. But it also revealed something about the nature of the Japanese character. And this really isn't physical science, but to me it's important enough to mention. Japan is an industrialized country, one of the tops in the world, you would say. They have some of the longest, maybe the longest life expectancy of any country in the world. And they have a very educated population, a lot of very, very positive things. But they also have a culture of basically taking care of each other. And what happened after that happened, after the tsunami wiped out the nuclear power plant? They had to go in and clean up some stuff. They had to go in and try to salvage and repair things. There were a bunch of old, retired engineers and others who had worked at that power plant and retired from it years earlier, but knew the power plant, and they said, wait folks, don't send in young people to do that, because the odds are they're going to get exposed to enough nuclear radiation that it could create long-term health effects, including death. And those older, mostly gentlemen, maybe women too, said, look, send us. We know the plant. We know what to do. We've had the training. Our lives are nearly over. It's not going to cost us as much as it will these younger guys and gals, and there's no reason to ruin their lives. Send us. My hat's off to the Japanese. That kind of self-sacrifice for the good of the whole country. I'm not seeing that too much in the U.S. these days. You know, I'm seeing all for me. Me. Okay. So anyway, did want to throw that in there, even though it has nothing to do with physical science directly. Okay. I've talked so long it won't advance. So let me click on the screen. All right. And now we get back to tides. Okay. We mentioned tides when we were in the Earth-Moon chapter. Here we are again. Now, some of what may have been in the book in those chapters, now they're showing up on the slideshow in this chapter. and it's worth going over again. The tides are produced mostly by the Earth-Moon gravitational attractions as described back in chapter 16, I think it was. Okay? However, they don't mention it here. The sun also has a significant gravitational pull on the Earth. It contributes a little bit too. So basically, because we have the moon going around the Earth, not exactly in a day, okay, a little bit less than a day is one pattern around, you basically come up with a pattern of 2 high tides and 2 low tides every 24 hours and 50 minutes, okay? So some days will only have 1 high tide because it'll have it right at the middle part of the day, and the next high tide will be very early the next day. But most days have 2 high tides and 2 low tides. So it happens every about 24 hours and 50 minutes, almost 25 hours, okay? Now, the reason for that, I think you remember from before, the gravitational pull of the moon and somewhat the sun on the Earth, it pulls the water and makes the water bulge toward the moon and a little bit toward the sun, and then the Earth is in the middle, the solid part of the Earth, and it pulls on the Earth too and makes a bulge on the back side, and then it repeats it when it's on the opposite side. So that's why we have 2 high tides and 2 low tides. The low tides are when the moon is perpendicular to the line, so of where you are, okay? So then you have your low tides, and it happens twice a day, most days. Now, the tides can produce strong reversing tidal currents in very narrow bays, and we talked about the one in Nova Scotia, if I can remember the name of the bay there. I don't remember. We did it back in chapter 16. Bay of Fundy, I believe it was, F-U-N-D-I. Okay. The way it's shaped and the shallowness and just the way it is, it produces, I think we said up to a 15-story building, or maybe it was 15 meters. I don't remember what. Huge. I think it was 15 meters, which would be a five-story building. Difference in high tide and low tide. And I thought, how in the world do you live with stuff like that? Sometimes water is up to here and sometimes it's way down there. It's just pretty amazing. But sometimes when the tides are that big and that impressive, they can produce strong reversing tidal currents in those narrow bays. When the tide's coming in, it's washing in rather rapidly. And when it goes out, it's also going out rather rapidly. And it happens twice a day. Actually 4 times a day. 2 highs and 2 lows. Well, basically 4 times a day. Okay? The tidal bore is the wave that moves rapidly up a bay as the tide rises. They don't have a name for it when it's moving back out, but it's still a pretty strong tow, an undertow that's taking you when you go out. Now I can remember, I don't know if any of you read mystery books. I haven't read many lately, but way back many years ago, there was one by Elizabeth George, who's really a famous mystery writer, and it was an unsolved murder mystery. Someone had taken the body out to a place where they had these strong tidal bores, and the body was put out there and then taken out to sea and never found again. They couldn't convict anyone of murder because they never had a body, but they were pretty sure, putting together everything they could, that's what happened, but they didn't know who did it. They just found enough evidence that knew it had been done, nor did they know exactly why, though they had several people. So anyway, that's the subject of fiction too, these strong tidal bores moving rapidly up a bay that can swamp people and kill them, or dragging them out to sea, which can swamp them and kill them as well. Really positive subjects today, right? So that's it for tides. Let's now move on to ocean currents. Now, These are as opposed to longshore currents and rip currents. Those are shore effects. The ocean currents are the things that are happening out there in the ocean. Okay? Now, this begins on page 624, very first, near the top of the left-hand column. That's 24-19. Excuse me, I'm going to have something else to drink. My throat's going dry on me. Okay, sorry about that. These are your ocean currents. These are literally, and this seems so bizarre, streams of water transporting water over large oceanic distances along roughly the same path in the middle of water. Okay, so wait, why would that be? Well, it's just like sometimes you have currents of air that flow like a stream, like a current. The other atmosphere is around just watching it, kinda, and they're taking off and going. This has happened. This is what we mean by ocean currents. A lot of times the ocean water is just sitting there. Other times it's being moved along large ocean distances along roughly the same path. Now, these are generally produced by two effects. The first of these are density differences in the seawater. Now, density differences occur for a couple of reasons. Now, I think we're going to talk about these separately, so I won't go into great detail here. The second of these are your wind blowing persistently in the same direction for a long period of time. Remember, we talked about fetch of waves and that kind of stuff. Same type thing here, but this is dragging water and that's making it move. Now, the part they don't mention here that I think should be mentioned, there's also the rotation of the earth. You know, that's the solid earth that rotates. The water gets dragged along with it too, but sometimes this creates some currents as it's doing it. So I think that should be a third one mentioned here. Maybe it's not as important as the other two, but it seems like to me it would have to be. Okay, so let's first look at the density currents. Now, denser water, because it's more mass per unit volume, tends to go to the bottom. Less dense water comes to the top. Okay, now there's three things that influence density. Okay, the first of these is water temperature. Colder water is more dense than warmer water. So colder water tends to go down, warmer water goes up. Basically the same thing we talked about before with air. It's called, goodness gracious. One is the stack effect, chimney effect. The correct name for it is convection. That's it, convection. Cold, dense stuff moving down, warmer stuff moving up. Okay, so that's one, water temperature. Polar water, of course, is much colder and therefore much denser than tropical water. So water in the tropics, warmer and less dense. So what you have is cold polar water moving down, warm tropical water moving up, because it's got to be displaced by something. Okay, now this next slide is absolutely amazing to me if it's precise or accurate. Okay, now this is showing Iceland here, Greenland there. We know they're fairly close to each other in the North Atlantic. And there are currents, we know, coming down from the Arctic. This is cold, dense Arctic water. Now that's located at 65 north, 65 degrees north. That's way up there. Getting close to the Arctic Circle. The Arctic Circle is at 66.6, so you're getting close to the Arctic Circle here. Not there yet, but close. Cold, dense Arctic water coming down. And look at this. Antarctic water? That's at the South Pole, coming up to 30 degrees north. That's going all the way under the Atlantic, down deep in the Atlantic Ocean, across the equator, Antarctic water coming up that far and coming as far as 30 degrees north. We're at 33 degrees north. Remember, 33 degrees 36 minutes and 45 seconds. So this is just below where we live, you know, except we're not in the Atlantic Ocean. Antarctic water coming up that far. Cold, dense Arctic water coming that far, hey, it has to be displacing warmer waters all along the way here. If these currents are going on down here near the bottom, that's forcing currents up near the surface. Okay, so the temperature differences produce density currents. That's mostly going down and up, you know, and when they're doing that, they're also following the grade, as you see here, down the coast of Iceland, down the coast of Greenland, and so it has some lateral motion as well as depth motion. Another thing that creates density currents, change of densities, is salinity. Salinity is the salt accumulation, and remember we talked about this earlier in this chapter. And they said back then it doesn't create a huge effect, but there is some effect. Okay? Now, what increases the salinity? One thing is freezing of water near the poles. You know, in the Arctic and Antarctic areas, when water freezes, what was salt water freezes, it's mostly the water that freezes, making the remaining water more dense because of the salt accumulation. Well, guess what? That's happening up here too. Water is freezing all along Greenland, Iceland, and further north, and therefore the water coming out of that is denser because of the salinity as well as the cold. So double effect here. Okay? Now, we also have evaporation effect. That would be more near the equator and in other warm areas, and now you're losing water to evaporation, making it denser with salinity because of salinity. But on the other hand, you have water running off of land, which is mostly fresh water. When it enters at river mouths and things like this, you now have lower density because you don't have as much salinity, hardly any salinity in fresh water as you do in seawater, so you're making the salinity less in those areas. Okay? And then the third density influence is from suspended sediments. And again, this mostly comes from river water coming in. The mighty Mississippi, I'm sure, brings lots of suspended sediments. We talked about that before. They pile up over time, making deltas. So yeah, they're bringing in sediments all the time. This produces denser water. So it produces turbidity currents in the oceanic basins. So all of these produce your density currents. Temperature, salinity, and suspended sediments. Let's now go to the surface currents. Those, as you see, especially the temperature ones, they go, well, density. Anything dense is going to go deep, the dense part, and the less dense part comes shallow. Well, the coming shallow, that can be a surface effect, but most of it is increased density, which is a subsurface effect. The surface currents, on the other hand, they say the global circulation patterns are maintained basically by patterns of prevailing wind. And I won't argue with them. I'm sure the wind, but guess where the wind is caused from? The spinning of the ocean, of the earth. Okay? Because the atmosphere, just like the water, doesn't have to be drug along, yet it is. So most of our winds, some winds are caused by pressure gradients, but the prevailing winds, that's what they're talking about here, are caused by the motion of the earth itself. So these surface currents, if they're not directly created by the spinning of the earth, they're indirectly because the prevailing winds are those prevailing winds because of the motion of the earth. And that's why it says here, also influenced by the rotation of the earth and the ocean basin shapes. Because guess what? The ocean floor is not level. It's not flat. It's not without significant features, okay? It has huge features in it. Now, here's a couple of terms. You occasionally see these outside of this, but basically this is where I see them most of the time. I think this is pronounced gyres. It could be gyres, and maybe it's pronounced both ways. These are great systems of water circulation centered in the mid-latitudes. And let's see if this next slide shows that. I think it does. Right here, the mid-latitudes, look at this circulation of water. In the South Pacific, it's down here is going basically counterclockwise. Here you have one in the Atlantic going counterclockwise. Here you have one in the Indian Ocean going counterclockwise. Okay? Now, unfortunately, it looks like this one's going clockwise here, but that's because it's in the northern, is both southern and northern hemisphere. Okay, the equator is right there. Okay, up here, clockwise. Over here, mostly clockwise. So in the northern hemisphere, these gyres are basically clockwise, and southern hemisphere basically counterclockwise, though you can have a few aberrations in that. Okay. Now I said that wrong. I was reading equatorial current. That's the Tropic of Cancer right there. Here is the equator right here. So most of this is in the southern hemisphere. Most of this is in southern hemisphere, and this is almost totally in southern hemisphere. This is northern hemisphere, and this crosses over. Okay, and that's why it's clockwise here, because this is the equator here. So yeah, that's a clockwise flow here. So these are gyres. The direction is dictated, as we've seen before, by the Coriolis effect. Now, if someone hasn't chosen a paper topic yet, who in the world was Coriolis? How did he develop this effect? What are the effects of this effect? What are the manifestations of it, the results, the contributions of it? There's several paper topics right there if you haven't chosen something already. Or just the fascination with these ocean currents. Now you see this current down here, they call it the west wind drift, and it may be because of wind, but it's also, I bet, because of the spin of the earth. Okay, can't say for sure. Maybe it's more wind than it is spin, but these go hand in hand. The winds, prevailing winds, and the spin of the earth, rotation of the earth, both contribute. This is that current we were looking at earlier, coming down between Greenland here and Iceland there, that cold Arctic current coming down here, sinking down here, and what's amazing to me, the Antarctic current traveling all the way up here. This is 23.5 degrees north, so that's 30 degrees north, traveling up that far, well over halfway around the earth to come up into the Atlantic Ocean. Unbelievable. Okay, so anyway, there's evidence it's there. Now, by the way, here are a bunch of your currents, and they list several of them: North Pacific current, North Equatorial current, the Equatorial counter current, the South Equatorial current, the Peru current. There's a bunch of them here. Here's the good old Gulf Stream. That's one of our most famous currents. I mentioned that before. It keeps all the east coast of the U.S. and some of Canada ice-free year-round, because it's warm water coming up from the tropics going up the coast here in one of those gyres or gyres. A little bit of that is what happens in the Gulf of Mexico too, and that's why it's called the Gulf Stream, because it's warm water from the Gulf makes its way out here and gets sucked up and carried. This is also what keeps most of Ireland ice-free, most of England ice-free, because this Gulf Stream goes that far. Okay, on the east side, it's cold. this is the North Sea over here. We didn't mention that before, or I may have. It's incredibly cold. These ports in here get iced over it very easily. Okay, these do not because of the Gulf Stream. Okay, Japan probably benefits from this current, keeping Japan's seaports free. Even though parts of Japan are very far north, they are pretty much ice-free because of that current. On the west coast, however, you have these currents here, some rather strange currents here. This one coming down here is the California current, and because it's coming from cooler waters down to the southern area, it chills things. I mentioned before, San Diego, California, as far south as you can go on the west coast before you enter Mexico. If you go to the beach out there, you better have on a wetsuit, because in the middle of summer, it is cold water. Not cold, but too cold to be comfortable swimming in. If you're in the Long Island, New York, and Martha's Vineyard in Massachusetts, and all these places here, go out there in swim trunks. And that's way north of San Diego, but the Gulf Stream keeps you very warm. The California current keeps it cold. But on the other hand, this North Pacific current brings warm water up here and keeps much of Alaska, this coast of Alaska here. Remember, Alaska goes down and eats up some of the coastline. It should be Canada, but we have it as part of Alaska, and then all along here, and even the Aleutian Islands, way far north there, they're mostly ice-free in the wintertime because of that North Pacific current keeping warm water flowing. It's not warm compared to what you would have over here, but it's warm enough to keep it from freezing. So you have bunches of currents listed here. I think there was one here. I think the Labrador current is mentioned. Yeah, there's the Labrador current. I can't read this. It's much easier to read in your book. Okay, the Atlantic current. Yeah, all these currents in here. You'll be seeing those on the lab, folks, so I wanted to point those out to you here. Okay? Now let's move to the ocean floor. Now remember, we mentioned the ocean floor back here in the ocean basin shapes. There it was. Okay? Here we're going to talk about the ocean floor. Now, let's get the graphic up here. Especially on the east coast of the U.S. and South America, you have what they call the continental shelf. This is still part of what was originally the continent, and still is part of the continent, but it's underwater. And it goes out quite a distance sometime, way out there sometimes, before it finally falls off. Okay? And I can remember when I was at Virginia Beach, playing around out there, you would sometimes see people standing up way, way out, it looked like in the ocean. Well, they were on a sandbar out there still on the continental shelf, and they were, sometimes you could actually see the sand at the top, other times it might be a foot or two deep, people walking around on that continental shelf way out to sea, way out to sea. That's the continental shelf. It's eroded continental margins. The land from up here, just like we talked about with the Mississippi River making delta, soil up here has been eroded and deposited out here. So it makes a shelf here. Part of that may be the edge of the continent too. It may be it was eroded away and its soil is down here now. And what was part of the continent here is now underwater. So eroded continental margins, relatively shallow water. Now, one ramification for that is a lot of things you would think would be great seaports may not be great seaports because all that water you see up there is great for beaches, but it's terrible for transporting big ships. Okay, so therefore the beaches take the shallow part, the seaports take the places where it's not as shallow, which works out pretty well. Then you have what they call the continental slope. That's where the continent finally falls off and has a slope downhill. Again, that could have one day in the long distant past been the edge of the continent there. That's the continental slope. The steeper transition feature beyond the continental shelf, and it's often cut by submarine canyons. In other words, where you've had strong currents that go down, wash out some of the land there, making a canyon just like the Grand Canyon on Earth, above the water, you make canyons underneath. And they can be quite treacherous for people who are scuba diving or other things like this. They're probably incredibly interesting to look at, but I would think they would be sort of treacherous at times. Okay? And then you finally get out to what they call the ocean basin. Now, basin usually carries with it the connotation of fairly flat. And a lot of it is, but that's the deepest part of the ocean, characterized by practically level, and it's called the abyssal plain. And they mention it here, almost level abyssal plain. Okay, I wish I could get there it is. That's the almost level abyssal plain. Usually some of the deepest parts of the ocean, not the very deepest, but you can also have mountain ridges in them. Okay, and here are a few of those seamounts that just pop up there in that abyssal plain. Now, you might say, why are they there? I can't really answer that for sure, but remember we talked about stocks and batholiths and hogbacks and things like this that were underneath, that form part of your landforms. Well, that could happen here too. Now, most of the abyssal plain is basalt, but maybe some areas of the basalt you have more magma underneath that's pushed up and made these laccoliths or things like this, only they're underwater. Now, certainly you have one where you have the mid-Atlantic or mid-oceanic ridge, where you have the diverging boundaries and the magma comes up, becomes lava, overflows, and that builds a ridge in the thing. And in the middle of the ridge is what they call the ridge valley, but the ridge on either side, that's the mid-oceanic ridge, as in the mid-Atlantic ridge, but there are others. Okay? Now, trenches occur along the ocean basin edges. Now, like I said, the east coast of the U.S. is mostly gradual continental shelf going down to continental slope, ultimately to the abyssal plain. On the west coast, both of the U.S. and in Europe and Africa and other places like that, that's where the oceanic crust is subducting under the continental shelf or crust, and the other part, this is where you run into trenches, really deep trenches. So whereas it said the ocean basin is the deepest part of the ocean, this is really the deepest part, those trenches. Now, they're usually in the ocean or adjacent to the ocean basin, so in that sense they're still part of it, but those are the very deepest. Now, this is a trench caused by the oceanic crust subducting under the continental crust. Okay, and that creates a deep trench. I remember going out in the Atlantic, or actually coming in, Pacific, or actually more likely coming in, especially when I was on the submarine that one summer. The depth, as you got closer to land, it gradually was getting less and less depth, but then right there off the coast, it just went down really rapidly, and then it came up very rapidly. That was that trench between the oceanic crust and the continental crust. The really deepest part is oceanic crust subducting under other oceanic crust. Boy, those trenches can be very, very deep because both of those are dense crust and they both get pulled down. That's the very deepest part. Now, the trenches occur along the ocean basin edges, but also ocean crust edges. You don't realize there's ocean basin edges because it's out in the middle of the ocean. We'll talk about those a little bit later. Volcanic peaks form with scattered seamounts. These could be volcanic. They more than likely are. They're definitely things like magma intrusions. Whether they actually form volcanoes or not, they're magma intrusions, the seamounts. The Hawaiian Islands and the Japanese islands and Iceland and the islands with Iceland, the islands of New Zealand, many of the islands in Indonesia, those are just about all volcanic peaks that have actually were seamounts that made their way, continued eruptions, made them break the surface, and they become islands then. So those are volcanic peaks. Many of those are underneath the ocean. Many of them are near the surface. Many of them break the surface. Okay. Now, continuing this on the ocean floor, here is a showing of some of these features. What you see here are your trenches and your ridges. This, of course, is the Mid-Atlantic Ridge, and remember Iceland is part of that, where it actually did break the surface. And this probably isn't exactly accurate, but it's pretty close. And you see it almost always splits halfway between Africa and South America, Europe and North America. This is the part that seems a little out of whack here. It seems like it should be moving more like that, but I don't know if these are actually accurate. But you see, it's not just mid-Atlantic. You have a ridge between the African plate and the Antarctic plate. You have a ridge right in the middle of the Indian Ocean between the African plate and the Indian Australian plate. You have another ridge down here between the Australian plate and the Antarctic plate. Over in the Pacific, you have ridges. This is the East Pacific Ridge here. Now, this is not between, how to say this, well-defined, I would say. Well, I'll take that back. If you remember, the Nazca plate is right in here. So this is probably a ridge between the Nazca plate and the Pacific plate. This is not caused by, I don't think, a diverging boundary. I think this is probably a converging boundary where you make the ridge here. I can't say that for sure. They don't say it in the book. But there's a Mid-Pacific Ridge that runs through here, East Pacific Ridge there, the Hawaiian Emperor Ridge, that's where the Hawaiian Islands are. I don't know what exactly caused that, if it's a weakness in the crust, and that's why it came there. It's just as a ridge. I don't think it's a separation ridge like the Mid-Atlantic Ridge is, but there is a ridge there. They have measured it. So there are several of your ridges. Now, also your trenches are where you have subduction zones, either oceanics subducting below the continental plate, like the Peru, Chile trench here. The east, this is the Middle Atlantic Ridge trench here. The Puerto Rican trench here. The Aleutian trench here. That's one of those island trenches, subduction zones, oceanic to oceanic. Your Tonga Trench over here, the Carnatic, I guess is how you say that trench here. Out here you see just tons of them. The Sundra Trench here, barely in the Indian Ocean. Mindanao Trench, that's on the largest island in the Philippines, area-wise, is the island of Mindanao, and this is a trench that largely that. Here is the Marianas Trench. The Marianas Islands are here on one side of another. The most well-known of those is probably Guam. I've been on Guam. That's the deepest trench in the ocean. The deepest point in the ocean is this oceanic trench between, and it's called the Marianas Trench. But there's several others, New Britain, New Hebrides, Japanese Trench, Kuriil Trench. This, I think, is part of the Aleutian Trench. I'm not absolutely certain, but it looks like it is. They don't have a name for it. So anyway, there are some of the trenches, mostly subduction trenches, where oceanic crust is either subducting under continental crust or under oceanic crust. Okay? So those are your major ridges and trenches, or at least some of them. And that, folks, is the last slide in the book, in the chapter. But before we go too much there, and I should have said this earlier, here is the person behind the science in this chapter, and it's Rachel Louise Carson. And she was a U.S. biologist, conservationist, and campaigner. She's the one who is really one of the biggest features for getting Clean Air Act, Clean Water Act, a lot of things like this, especially trying to clean up the oceans. Now, we have a very, very bad habit of messing up just about everything we touch, okay? And what we're doing now is dumping a lot of our garbage out in the ocean. Guess what? Is someone going to say something?
I was saying, don't let me get started.
Oh, yes, okay. We have dumped so much plastics out into the ocean, and of course the ocean beats the plastic up until it becomes, and plastic degrades, not biodegradable, but it's photodegradable, meaning sunlight will break down plastics, okay? The lighter, clearer plastics break down more rapidly. The darker plastics, it takes a little longer. I believe I'm right on that. And if you've ever had plastic that sat out in the yard for a long time, you went to pick it up and it is very brittle, that's because it's been photodegraded. Well, that happens in the ocean, and the plastics break up. This is plastic bags, plastic bottles, plastic just about anything. We just dump into the ocean. We let it wash out to sea, and there are huge areas of the ocean that are now almost dead. The reason is there's so much plastic there. Plastic will break down to the tiny little pieces that are about the same as plankton. And the plankton is the number one thing in the food chain of just about all the oceanic animals. You know, the fishes, the whales, the sharks, everything else. The smallest things eat the plankton. They get eaten by other things and stuff. Well, they go to eat this plastic thinking it's plankton. Oh, here comes Amari. Good to see him coming in. Let me get him marked here. There's Amari. All right, that should have us up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 students. That should be a total of 13. Is that what we got? Yes. Okay. So, Angelina, I take it you're quite a conservationist, are you?
I am, yes.
Excellent. You and Rachel Carson should get along famously, okay? I think you've already written your paper, but that would have been an ideal match for you, so you can read about her anyway. Okay. But this plankton we were talking about, Amari, who just came in, we're basically through with the chapter. We just talked about the last things in it. This plankton is what feeds everything else in the ocean. When the plastic breaks up into plankton-sized material, those other sea creatures go and eat the plastic rather than plankton. There's no nutritional value in plastic. In fact, it probably clogs up their whole systems. And ultimately, they starve to death trying to eat more plastic, thinking it's plankton, and ultimately, we lose them. And when we lose them, we lose the next thing in the food chain, and the next thing, and the next thing. So we have created huge areas in the oceans that are basically almost dead. And that's tragic, because we depend on everything on this planet is interdependent. We depend on what's happening in the ocean. Now, another thing we've done is we've overfished like crazy. This area about where I'm putting my thing was called, I think, the Sargasso Sea. And that was such a rich fishing area. It's off the coast of basically, I think, Nova Scotia and parts of Canada there, maybe dipping down as much into the part of Maine and maybe northern New England there, but goes way out into the sea. That was one of the most prolific fishing areas in the world. Just tremendous numbers and size and everything. And I mean, when I say we, it's not just U.S. Europe, all over the place, just fished it to death. Now you can hardly catch anything out there. We messed up their ecosystem so badly. We're in the process of doing that in the Gulf of Mexico. Everybody loves their, oh boy, what's the name of that? Red is in it, the name of the fish, I think. Grouper is one. Red snapper, grouper, all these other things, we have almost fished that to death. You can hardly get it anymore. We are messing things up big time. And of course, the Gulf oil spill probably messed it up even worse, okay? That was a major disaster, okay? Also, and this is more the fault of the Japanese, probably the Russians to some extent, maybe the Europeans as well, basically went out there and just were killing whales till like there was no tomorrow. Okay, we participated in that some, but I think we backed off before many of them do. And some of them, the Japanese, are notorious for still going out and overfishing and over whaling and doing things. So on the one hand, we're polluting the oceans like crazy, killing it from the, you might say, the ground root up, and then we're taking off the prime product, so reproduction and stuff like that is not as good anymore. We're doing a miserable job of policing ourselves and trying to maintain the ecological health of our oceans. Number one, we don't know enough. Number two, we're greedy. Okay, and maybe that should be number one. I don't know. All right, that ends the chapter. And as I say at the end of every chapter, nothing in the world replaces reading the chapter. I can talk about it till I'm blue in the face, and you think I do and am, but nothing replaces reading the chapter. Please, if you haven't read it already, read it. If you've already read it, now that we've talked about it, read it again. Okay, nothing replaces that. After reading it, you'll find the summary is usually quite pretty useful. Okay, it hits some of the high points, but you miss so much if you just depend on the summary. I don't know if any of you remember back in the when I was a child, Reader's Digest basically took big things and digested them down into smaller things. People enjoyed reading Reader's Digest because it was shorter. Well, then they had condensed books, and they would get maybe 4 or 5 books where normally you'd have one. They'd leave out so much of the detail, and maybe some of it wasn't totally important, but it was still so valuable. Well, that's what the summary does. It leaves out a lot of detail. So don't count on the summary. Though after reading, it's a good thing to summarize. That's what it's there for. Then you have your key terms. This list is probably a little bit shorter than normal, but maybe close to normal. And then you have applying the concepts. And this chapter has 46 questions, which may be just short of average, but pretty close to it. All multiple choice. Most, not all, but most of your questions on your test will be multiple choice. Not the same questions, but many of them covering the same material, just asking a different way. So if you know the answer to these, you probably know the answer to the one on the test. The answers are given here in the book, so test yourself here with these conceptual questions. Then you have questions for thought. There's only 13 of them in this chapter. That's fewer than normal. For further analysis, 6, maybe 1 or 2 more than normal. And then there's an invitation to inquiry if you're interested in looking into that. The parallel exercises are kind of thrown in there. Some of them will be somewhat interesting, but I'll let you decide whether you're going to do those or not. All right, that finishes all the course material for the class. What remains, which we'll do on Tuesday, is the lab for Chapter 24. And folks, this is going to require your books, okay? If you don't have a book, then by all means go back and pull up today's lecture on the YouTube videos, because a lot of the things, it may be hard to read on it, but a lot of the things will be some of these figures like you see right here in the text. That's where you're going to be able to answer the lab. I could not find the lab that really worked well here, so I made one up myself based on the chapter in the book. So be sure, if you don't have a book, pull up that YouTube video, which will be posted by then. It'll probably be late tonight before it posts, but it'll be up there by Tuesday. Pull that up and use that as your reference for answering. It's not a lab we can really do in class. I can point you to the right directions, but you're going to be doing it individually. Now, if you want to work in groups and teams, that's what lab's all about. Go for it. But it's not something like I've done on some labs that we do everything and answer every question. This is something you'll be doing on your own. I'll be here to let you know whether you're heading in the right direction or not, but this is a lab that you're going to be doing either yourself or in groups if you can manage to do that. Okay? Then the test is a little bit different kind of test, not as different as test 6 was, but it's sort of not as much. Again, the test bank questions were just sort of all over the place, so I had to piece together portions of them, and most of them are multiple choice, but a few of them are not. So by all means, be careful working the test. Now, let me talk a little bit about the final exam. Very different kind of test. The others have been either fill in the blanks, like mostly Chapter 6 and a few other individual places in certain tests. Multiple choice, that's been most of them. The final exam is matching. On the left-hand side of the page will be a bunch of definitions, descriptions from all the chapters, all 9 chapters we've done. And on the right-hand side will be the words or phrases, but they won't be in the same order. There will be a blank by the word. You pick I think it's the letter of the definition or description that matches that word. It's going to be a pretty easy test. A single-page test, something on the order of 16 to 20 questions on it. You should be able to do quite well on that. Okay? So you can't drop the final exam. You don't want to drop the final exam. It should be one of your better scores. All right. Any questions on Chapter 24? On anything we've done up until now? Your research paper, any of the first 8 labs, any of the first 8 tests? Any questions at all? Okay. Do you want me to stay online with you for a while you work on collecting or gathering or answering things that you put off or behind on? Or would you rather have your computers or phones free to do that? So is it difficult for you to try to keep the Zoom up while you're trying to do that? You let me know. Anybody? And remember, labs, you can work with each other. So if you're having trouble in the lab and you can't get through to me, or you want to ask one of your classmates, yeah, do that. Okay? By all means. Even people who have sent me stuff, because it's sent electronically, they have the originals at home. So you can work with each other in the labs. If we were on campus, that would be the whole purpose of labs, is that you work together in teams. Sometimes the whole class is a team, sometimes smaller groups. But take advantage, do that now remotely as well. Help each other out. answer questions. Hopefully you all wind up learning something from it. So don't feel bad about working with others and asking others for help. Okay. Any questions?
Which lab number are we on again?
Okay, we have done 8 labs so far. The lab number 1 was the night sky. Remember that one? Way back, evening sky map. You answer questions on that one. Lab number 2 was the PDF that I sent from the lab manual. It was page after page.
Wait a minute, which one are we doing right now?
We're not doing a lab today. We're doing the chapter 24 lab. That's lab number 9. We'll be doing that on Tuesday.
Okay, so that's it. We don't have anything right now for caught up?
Yeah, right now, if you're caught up, you're caught up. So that's what I'm asking. Do you need me to stay on board any longer? Someone, I think, just sent a chat. I don't know if it's to me or to somebody else. Feel free to ask me questions. Okay, I couldn't hear you. Say that again.
I was saying I just put my phone number in there just in case anybody needed any assistance.
Oh, excellent, excellent. Yeah, because Angelita's on top of it pretty well. And Matthews, I think, turned in just about everything. So, yeah. Work with each other. That's what labs are all about.
Oh, yeah, Mr. Feller.
Yes.
So I noticed that, like, all my tests, most of them are graded except for 3 and 4.
Okay.
I don't think I sent those in, so I just resent them in.
Okay. Did you send them through Blackboard or through emails?
Yes,
Okay.
through Blackboard.
Okay, I'll be checking. The sooner I get off here, the sooner I'll start checking things and trying to get some grading done today. This class and other classes as well. So by all means, get me stuff today. If you do, I'll be doing this today, tomorrow, probably Saturday and Sunday as well, and some on Monday. I have some office hours on Monday as well. So I'll be trying, especially this class, because next week is our last week, folks. So watch out for those student course evaluations. If they do open them up, get those done. Get your research papers done. Get your tests and your labs done. Get everything into me that you haven't turned in already. If you've turned it in, but you haven't seen a result, it may be I just don't have it printed yet. But watch for it over the weekend. Hopefully you'll see more of the grades show up over the weekend. Then if by Monday you're still not seeing something, then either quiz me on it, ask me if I've got it, I'll look for it, see if I can find it, and if I can't, you can resend it then. But yeah, I appreciate you doing that, James. Okay, any other issues, concerns? I see a lot of people are sending chats, up to 9 now. I imagine everyone's sharing information. So that sounds great. Any other issues, concerns? Do you need me on here? I'll be glad to stay on and answer questions as long as you have them. Anybody? Good? All right, well then I'm going to stop the sharing now, and I really feel bad. I'm cheating you out of, goodness gracious, hours of your tuition dollars. But y'all have been a great class as far as moving right along, getting things done. Appreciate that. I hate the fact that we couldn't go on the 2 field trips that we'd normally go on, but COVID has wiped that possibility out. That's one reason we're a bit ahead of schedule. We would have gone to a planetarium if we could have, back after chapter 16, and we would have gone, if we could, to Channel 13 Weather Center after chapter 23. But both of those field trips, and those, basically the field trips didn't take the entire time, but they took a huge chunk of time out of those 2 classes. So that's what threw us basically ahead 2 classes, almost 2 days, and that's why we've had light Thursdays the last couple of Thursdays. Today is very light, and then Tuesday will be very light, and Thursday will just be turning everything in. Okay? Any other questions, thoughts, concerns, issues? Okay? If you're going to get your chats out there, get them done now, because once I end the session, I doubt if you can do it anymore. But if you got the information, then you can call and interact that way as well. So you want me to end the session? Okay, folks, I don't hear any objections. So have a good weekend. Of course, to make it a good weekend, be safe. I know it looks like it's going to be a beautiful weekend. There's a real tendency to get out there, but folks, don't push it. The virus is still there, okay? So take care, be safe, get your work done, get the research papers done, the tests and labs caught up, and we'll look forward to seeing you on Tuesday to do the Chapter 24 lab, and then I'll give you the Chapter 24 test, and sometime after that, the final exam. So take care, be safe, and get your student for course evaluation. Keep watching for that. And was that a question for me?
No, sir.
Okay.
I'm sorry, I made a mistake. I'm sorry.
No problem. Take care, folks. We'll see you Tuesday.
You too. See you Tuesday.
Bye-bye.